maths have to do with a lot of varieties. Just as in real life, we could see things that though they are not the same directly, they may come in the same form. Okay, for example, words. Like instead of saying it's not, which other way can I say that? It isn't, right? Or which food? Jollof is what, rice and? Or fufu can be called what? Pounded yam, right? Yeah, pounded yam. So it looks like, or wache can be rice and beans. So that's something which have the same value. So wache is equal to rice and beans. Anywhere you see wache, you can replace what? Rice and beans. So that variety also, it's in math to an extent. So let me give you a fraction like this. And then I'm taking out a part. Okay, what fraction is this? Okay, 1 out of 2. So we have 1 out of 2. That's careful. And I divide this into 4 parts. How many parts have I taken? 2 out of 4. But has the size I've taken changed? No. Has it changed? No. Okay. Agreed? Has it changed? I mean, I took just this part. Hasn't changed. All right. What if I cut it again into? Okay, let me use a different color to make it come clearer. What if I cut it into this other part? I cut every part into 2. How many parts have I taken here in this thing? 4 out of 4 out of 8. Okay, we could cut on and on and on. We could divide in further sizes, right? So this concept, you said? Yes. So this concept is what we have a name for, called equivalent fraction. Say after me, equivalent fraction. Equivalent fraction. Please be careful, okay? Now, what word? I think the words alone, we could break down the words and understand what it means. Equi. Who has come with any? Who knows any word that has equi, EQU inside somewhere somehow? You? Equal. A word with equi that relates something equal. You know the equator. When you take the earth, the middle part, the parts that divide the earth into 2 different portions, is called the equator. So equivalent has to do with. So you could define. How then do you define equivalent fractions? How then will you define equivalent fractions? Okay. Yeah. Any other way you could define equivalent fractions? Okay. Observe carefully. Look at, they are different. Can you see that? Any other? Want to give a try? How will you define that? Yeah, they are the same. That are equal, yeah. So we'll say that equivalent fractions are fractions with the same value. Very important to a same value. Please follow. Same value, but different numbers. Where the numbers here will be the numerator and denominator. Please, are you following?
Yes.
All right. Where the numbers here? So they have the same value but different numbers. Where the numbers here are the numerator and the denominator. So this is basically what we call equivalent fractions. How then do we? So mathematically, if we could observe, all right. If you could observe the relation between this, you realize that there is an arithmetic operation here. So that would be, let's try what could be happening here. Please pick that and put it on the table. So 1 times what gives you 2? 1 times what gives you 2? 1 times what gives you 2? Attention here. 1 times what gives you 2? 2 times what gives you 4? Okay. So 2 times what gives you the 4 over here? The same 2, right? Times 2. 4 times what gives you 8? 4 times 2. Is that okay? Alright, so we could therefore, having done this for some time, we could therefore establish a rule that when you multiply the numerator and the denominator with the same number, you get an equivalent fraction. Is that okay?
Yes, sir.
Is that okay? Alright, so let's try this. So quickly write equivalent fractions for this number. So we have, let me do the first, 2 over 3. And I want to get all I'll do is I can just take any number at all. Maybe 2 times 10, 3 times 10. I get what? 2 times 10?
20.
And then 3 times 10. 2 times 10 is 20. 3 times 10 is 30, right? So we have 20 out of 30. How would you? So let's take these examples quickly. Find equivalent fractions for 2 over 5. Are you writing? Find equivalent fractions for 2 over 5, 3 over 4, and then 5 out of 7.